So we'll do a lesson here on sketching straight lines. It's fairly straightforward. There's two ways of writing a straight line. There's our slope-intercept method, which is written y equals mx plus b. And there's our standard form, which we looked at last class, which is ax plus by equals c. And I think the book does plus c equals 0, but for IB we usually go for equals c. So let's just put both of these into a cloud. Love my clouds. And then we're going to look at an example of each to see how we can plot these. So question 1 might be to sketch y equals 2/3 x minus 4. So we know straight away this is the slope, and we know straight away that this is the y-intercept. So it becomes fairly easy what to do, and we've done this before. So we can put a little mark on -4, which is the y-intercept, and then the slope is rise over run. So the rise is 2, and we know the run is 3. That's what slope means. So we're going to go up 2, 1, 2, and across 3, 1, 2, 3. We put another big dot, up 2, and across 3. And all 3 of those red lines should be in a straight line. And of course there's a straight line coming down. It just about fits. We can mess around with this a little bit, I hope. There you go. And there is our straight line running through. What we're going to do is just make sure we label it y equals 2/3 x minus 4. So always label your lines when they're on the graph. Over here, question 2, we're going to look at another example here. Let's go for 3x plus 2y equals 6. For a question like this, we could of course transform it into y equals mx plus b, but there is another neat little method we can use, and that's drawing a little t-chart. And this is the sort of thing we need to get in the habit of doing. And we're going to look at the x and the y-intercept. So if x is 0, we can look at what's happening when the x disappears, because if we were to substitute x into here, we would get 0. So therefore, what would happen if x disappeared? Well, of course, x was 0. Well, of course, this would become 0. And we get left with 2y equals 6 and y equals 3. And that would go there. And the other thing we're going to look at now is what happens when y is 3. Well, if y is 3, 2 times 0 is 0, and we get 3x equals 6, because the y is gone. And divide by 3, x equals 2, and that 2 goes there. So now, just get the equation back where it was, get rid of this little box so I can. It's gone. So now we're going to graph 2 points. We're going to look at the 0, 3 point. So where's the point 0, 3? Well, it's there. Let's put it in blue, different from the other graph. 0, 3 is there. Where's the point 2, 0? 2, 0 is there. Can we come up with a line now to connect those two blue lines? Yes, we can. It's just a matter of whether we can get it to be straight enough. Let's have a look. That's not bad, is it? Maybe just over a bit more. That's perfect there. So that is the line 3x plus 2y equals 6. So let's have a look at another couple of examples just to get you on your way. So we'll do y equals -3 over 2x minus plus 4. And we'll look at another one, 3x minus 2y, again equals 12 this time. So we'll do the y equals mx plus b. We know the y-intercept is 4, that's there. And we know the slope is negative 3 over 2. So it's down 3, 1, 2, 3, and across to the right 2. Put a big red line, down 3, and across 2. And there's our line there. And we just need to get that line so that it goes through all 3. I'm getting better at this, it's not bad at all. Perfect, let's just write on the line y equals negative 3 over 2x plus 4. And then for the other line, I'm going to do a little t-chart. If x is 0, we get negative 2y equals 12 because this bit has disappeared when x is 0. Y equals negative 6, that goes there. And if y is 0, this bit disappears and we get 3x equals 12, x equals 4. So where's the point 0, negative 6? That's there. Where's the point 4, 0? That's there. And all we need is a line. And that looks good enough. Not bad at all. And that's the line 3x minus 2y equals 12. So now we're going to put the homework on this sheet. Homework there.